So the genius of Bezos, okay, and we know who Bezos is, okay. He's the founder slash CEO of Amazon.com, which hopefully you guys use, or at least you will be using at some point. I use it pretty frequently, especially now, right? So forget about Amazon. Let's say Amazon didn't exist, okay, and you were relying on a brick and mortar retailer in those days. Let's say Walmart, okay. And Walmart had, say, you were living in a pretty large city, okay, and it had two stores at the opposite ends of this relatively large city, okay. And store one, because it was further away from population density, had, and this is basically demand for a product in store one, they were tracking, okay, as to, let's say it's a product, let's say yogurt, okay, let's say store one was selling yogurt, store two is selling the same yogurt, okay. Of course Walmart, any given Walmart or any given Target or any given grocery store could have thousands or maybe tens of thousands of items, right? So we're just going to pick one item and we are going to sort of look at the demand for that item. Demand means as to what customers are buying over time. And as you can see, we are tracking, say, weekly demand, okay. As you can see that every week the demand for at store one for this product, for the same product, for product A, okay, is pretty stable, okay, because it's a food item and you expect that, because regardless of what happens to the economy, regardless of what happens to the weather, if you need milk or if you need yogurt, you're going to buy that milk or yogurt, right? So you're not expecting a lot of volatility around that thing, which is what you see here, okay. But because the density is low, the population density is low, you don't have as much average demand, okay, for that product in store one. Population density is high, maybe it's in a touristy location, so you can see a little bit more standard deviations, more volatility. Let's say it is more exposed to, let's say this is downtown SF versus a suburb of SF, right? And if it's in a downtown SF, you're going to expect a lot more folks coming from out of town, and they are technically wreaking havoc on your supply chain by you being exposed to that volatility, okay. But you want to make money, so you want to stock up. So what is the implication of having this volatility, okay? Ideally, if I were running that store, I would want to see a very flat line, okay, as flat as possible, because that volatility means that if I want to make sure that I don't piss off customers, okay, if they come to buy something, okay, if I want to make sure that I don't piss off customers, I want to make sure that I stock off enough and I overstock to an extent, okay, so that whatever customers comes through my store, they are going to be able to get the product they want, okay. Of course, I'm going to overstock means I'm going to carry more inventory in stock. That means I'm going to incur a cost of carrying that inventory, okay. So carrying inventory is not free, right? And inventory for a retailer, especially with respect to waste, if it's a perishable item, can be a huge cost, right? So you're going to overstock, right? So you ideally want a very small standard deviation around you. So you can convert this data, okay, and let's say you can plot it in a distribution form, okay, and we are using that same information. We are looking at distribution. So store one had a lower mean demand, okay. Store two had a higher mean demand, but store two had a wider distribution because it has a higher standard deviation. Store one has a smaller standard deviation, okay. So we talked about, because it's a tighter distribution, because the volatility was not that high, okay. Now let's say you're an online retailer, okay. Online retailer can serve both population. Let's assume that somehow it can deliver to a hotel, to a tourist visiting instantaneously, with a central distribution center which is exactly in between these two stores, okay. Let's say that distribution center is managed by Amazon, and Amazon can deliver to you in, say, 30 minutes, okay. regardless of where you are. You just text your address and they will come and deliver whatever you ask, right? The fact that you can combine, so the demand doesn't change, so you just add up the two demands. So as we say, sum of those two means, right? So x plus y equals ex plus ey. Okay, so you can just combine those two means. Okay, so the mean demand doesn't change, but the volatility, the variance. So remember, you have to overstock in store 1 as a brick and mortar retailer. You have to overstock in store 2 as a brick and mortar retailer. Not as much as in store 1 because the distribution is very tight, but a lot more in store 2 because the distribution is very wide. There is a lot more volatility, so you'll store more, right? But the fact that variance is add and not standard deviation, it so happens that the online retailer does not have to store as much in safety stock or excess inventory as opposed to a brick and mortar retailer, because when you combine variances of these two distribution, as we just saw, even though there is a very high covariance term between these two, and it is expected, okay, assuming that there is a very high covariance for this item in these two different stores, when you combine these two distributions, the effective standard deviation is actually smaller than the combination of each, than the individual standard deviations of these two stores. Okay, so Amazon or any online retailer actually can carry a lot less inventory in excess. So there is a lot less wastage and there is a much more improved efficiency, right? And all there is, okay, technically, if you really look back at it from a very high level view, is this math. Okay, so imagine this power. Okay, Amazon is like $1 trillion company now. Based on this simple, of course, there is a lot of logistical challenges and complexities around how they run their supply chains and all, right? But look at how simple the math is behind the fact as to why Amazon and the likes of Amazon and the likes of other online retailers will from the efficiency perspective, from the cost perspective, will always outwin a brick and mortar retailer, right? So there is that. So there is an application of. You're not just learning all these things for no reason. There are a lot of applications to that, right? And this is just one. So we're going to go back to our portfolio, our individual portfolio model, and see how we can apply this math and combine variances and design a good portfolio. Okay.